Glad you can make it. We're gonna steal the moon! Just kidding. That's not possible. You should have seen that in the plot of Despicable Me. But for today, we're going to talk about what is the moon. Well, the moon is our closest neighbor in space. The moon is a natural satellite that orbits the Earth, and it's held in by our own gravitational pull. In general, a moon is just any natural satellite that orbits a planet or an asteroid, but our moon orbits Earth. Okay? Our moon is one of more than 96 known moons in our solar system. So there's tons of moons out there. There's moons on other planets, but there's also moons on just asteroids. Because when a celestial body has enough mass, it has a gravitational pull. And when we have that gravitational pull, sometimes other objects can be pulled in. And if those other objects are pulled in and they orbit that celestial body, it's gonna be classified as a moon. Planet Earth only has one moon, as hopefully you know. So, where is Earth's moon? I'm glad you asked. It's about 384,000 kilometers from Earth. If you're interested in what that value is in miles, it's 240,000 miles-ish. Just for funsies here, I know this isn't part of our lesson, but let's write this value out in scientific notation, because we know how to do that now. So, for scientific notation, remember that we look at where our decimal is currently located, and since it's not otherwise indicated, we assume it's at the end of our value, and we want to move it over until there's only one value to the left of our decimal that is not a 0. So, we want to end up with a value that's between 1 and 10, not including 10. So we're going to scoot it over, and we're going to do that 1, 2, 3, 4, 5 times until we get an n value of 3.84. And for our a value, our exponent, we moved it over 5 times, so we get a 5. Is it going to be positive or negative? Well, we move that decimal place over to the left, or we could say, hey, look at that number we started off as. It is a large number, a number bigger than 10. So it's going to be positive. So our scientific notation of this number here is going to be 3.84 times 10 to the power of 5. Anyways, that was a cute little aside. In terms of our size of our moon is 3,468 kilometers in diameter. So going from the top of the moon all the way through to the bottom of the moon, that is about 2,155 miles. So if you want to look in terms of comparison, it's about a quarter the size of the Earth. So still quite large, but not larger than our Earth. And look at it, this is our moon. Well, this is half our moon, we can't see the other half. And this is our Earth. And just for funsies here, what side would our sun be on in this photo? Our sun would be on this side here. Because if this is our sun, whenever I draw a sun like this, it reminds me of a lion's mane. Our sun is beaming out light, and it's going to hit this side of our Earth and this side of our moon. Alrighty, the moon's surface. So something cool to know about the moon is it has no atmosphere. There's no liquid water on the moon's surface. And the moon experiences extreme temperatures. So at daytime, it's crazy hot. 130 degrees Celsius. Which is probably why there's no liquid water on the moon's surface, because water boils at 100 degrees Celsius. At nighttime, it's just freezing cold. Freezing cold. At negative 190 degrees Celsius. So if you think about it, because it has no atmosphere, it can't keep those temperatures regulated like we can on Earth. Because we have an atmosphere, we trap in some of those, that heat from the sun, which is why we have livable temperatures on Earth. The moon doesn't have an atmosphere, that's why we get some wild temperatures. Another thing about the moon is it has about 1/6 the amount of gravity as Earth does. That's why when you're on the moon, and you could see those astronauts jumping from place to place, it kind of looks like they're jumping in slow-mo. It's because there's not as much gravity, so they're not being pulled down towards the surface as strongly as they would be on Earth. Kind of cool. All right. The moon has different features. We could call those lunar features because the word lunar refers to the moon. Kind of like solar refers to the sun. So the moon is composed of different landscapes. It has highlands, it has craters, and it has something called maria. I know it just looks like Maria, but it's pronounced Maria. The lunar maria are dark, large, and basaltic plains on Earth's moon. Back in the day, early astronomers mistook them for seas. So from Earth, they looked at them and they're like, man, those look like large bodies of water. In fact, it is not. But the word Maria is actually Latin for the word seas. So that's where it got its name from. If you're curious, so Maria is Latin for the word seas, so singular would be a mare. Kind of cool. All right, so this is what a mare would look like here. And these are what craters look like. Okay. All right. So, movements of the moon. So, the moon rotates on its axis about every 27 days. The same side of the moon is always facing the Earth. The reason for that is that the moon also revolves around the Earth. So the moon orbits the Earth every 27 and a third days. So because it's revolving essentially at the same rate that it's rotating, we're always looking at one side of the moon, which is kind of crazy. Because technically, the only way we could see what the other side of the moon would look like is if we sent up either satellites or people up to space to check it out. And we have, and that's cool. But from Earth, if we didn't have the technology that we do today, we would never have been able to figure out what the other side looks like. So that's kind of neat. From our perspective, the moon rises in the east and sets in the west, same as everything, because it's also rotating in that direction. All right, phases of the moon. The moon does not make its own light. It's not a star, it's not something that produces light, but instead the light that we see from the moon is just reflected from the sun. Okay? At any given point, half the moon's surface is always reflecting light. But from our perspective, from Earth, we can see different amount of the moon's lit surface, depending on where the moon is located, and where we are located in terms of the sun, or in reference to the sun. So that's why we see different amounts of light or different phases of the moon, but half the moon is always being lit. So that's kind of neat. And here in this diagram to the right is actually quite a common design that I've seen on oodles of t-shirts everywhere lately. But anywho, these are pictures of the different phases of the moon. Okay. So sometimes part of it's lit, sometimes none of it's lit, sometimes all of it's lit. But that's just from our perspective. In reality, at any given point, half of the moon's surface is always reflecting light. The phases that we see, these are just from our own perspective. So if only part of it is being lit in our perspective, then the part that we can't see, the other piece is being lit. Alrighty. Boop, boop, boop. Ah! Yeah. Okay. Alright. Waxing and waning. So when we're describing the different phases of the moon, oftentimes you'll hear us use the vocabulary waxing moon or a waning moon. What that refers to is what side of the moon is receiving light from the sun. Okay? Waxing refers to more of our side, more of the Earth side of the moon is receiving light from the sun, and the light increases as night goes by. And waning means that less of our side of the moon is receiving light from the sun, then this light decreases as night goes by. So, what that really means is if I'm looking at waxing or waning, I need to establish sides. And I've kind of done so. I've pre-drawn this here. So picture the sun here on the left-hand side, the earth here on the right-hand side. And I'm going to draw the moon. And I'm going to draw just this purple circle here. It's nice and purple. Okay. Now, in white, so the moon, that's the purple moon there, I am going to draw what part of the moon is being lit up. Okay, so the white represents the part of the moon that we can see light on in this particular point in time. And what side is dark. So in this case, the earth side is receiving most of the light, and the sun side is receiving not a lot of light. So if the earth side is receiving light from the sun, that is a waxing moon. Because we say more of our side, more of, we could say earth side of the moon is receiving light. If we had the opposite, so we had the moon, okay, and this is what we saw from Earth. This time we see more of a crescent-y shape. I don't know. In this particular case, more of the sun side, or less of the Earth side, is receiving light from the sun. So we call this a waning moon. So that's how you can tell the difference. So if we're looking at what side the Earth is on, what side the sun is on, if more of the Earth side is receiving the light, that's waxing. If more of the sun side is receiving light, that is waning. All right. So in this particular case, here is a diagram of the different phases of the moon. So we have these different phases here. So we have the new moon, and we can see the new moon over here. The new moon is when we don't see any of that light. So from Earth's perspective, we don't see the moon at all because the back half of the moon is receiving all that light, but our side that we can see from Earth is not receiving any. So that's the new moon. Then just going around here, we have the waxing crescent. And again, if this is Earth side on the right here, the Earth side is receiving more of that sunlight, so it's called a waxing moon. Then we have the first quarter moon. We don't call it a half moon because from our perspective, right, the moon has a front and a back side. We only see the front half, and only half of that half is lit, which means it's a quarter. So we see a quarter moon. Here we have a gibbous moon or a waxing gibbous moon because, again, more of the Earth side is receiving that light from the sun. So here we have, I'm going to do it in different colors. In these three images, this crescent, this first quarter, and this gibbous, these are all waxing moons because more of the Earth side is receiving light from the sun. Then we've got the full moon. The full moon just looks like the whole moon's lit up from our perspective on Earth. And then we go backwards. So we have the gibbous moon, the waning gibbous moon, the third quarter moon, and the waning crescent moon. These are all waning of the three up here. So this is waning, this is waning, this is waning. Because more of the sun side is receiving light from the sun. More of the moon's sun side is really receiving sun or light from the sun. Man, words are hard. Okay. There we have it. Phases of the moon. So there's 4 basic shapes. Okay. So there's the full moon, which looks like this full, bright, lit up circle. We have the crescent, which is pretty much the typical go-to, how do I draw a moon as a 3-year-old? It's this little shape there. We have the quarter, which is half of our half that we are witnessing. And then we have the gibbous. And the gibbous is like the part of the moon that no one ever draws. It's not quite a full circle, but it's like an opposite of the crescent, right? The crescent is dark in this particular case. But those are the 4 main shapes. And if you think about it, you could make all of these by eating Oreos. So if you had an Oreo, just for funsies here, boop, 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 icing. Look, I have an Oreo. And you, cut it in half. Well, not cut it, you twisted it. And so you have this Oreo. Boop, boop, boop. You have the icing. This is your perspective from the inside of the Oreo. This perspective would look like a full moon. Whereas if you ate some of the icing, maybe half of the icing in a particular nice way, you could eat through to a quarter. You could eat through to a gibbous. You could eat through a crescent. Obviously, if you want to only eat one Oreo because you're limiting yourself, I don't know why, eat as many Oreos as you want, then you would probably go full first. Then you'd go gibbous, and then you'd go quarter, and then you'd go crescent, just in terms of like what has the most icing, what has the least. But if you want to do 4 separate Oreos just to really understand the phases of the moon as best as possible, you could also do that. Anywho, pro Oreo. And again, here we have another diagram of the phases of the moon, when they're waxing, when they're waning, all of that fun stuff. Keep in mind that remember that at any given point, the moon is always half lit. So just because we can't see the full half that's being lit by the sunlight, the moon is always half lit. It's just depending on what perspective we see from Earth that gives us the different phases. All right. The next thing we're going to talk about eclipses. And I briefly mentioned this in another video that you would have seen already, but we have an eclipse. And what an eclipse is when you have the sun, the moon, and the Earth. The Earth, all in one line. So they're all lined up. We have 2 different kind of eclipses. So we have a solar eclipse, and the solar eclipse happens when the moon is in the middle. So the moon exists right between the Earth and the sun. And so on Earth, we see this picture here. So we see the sun, but then the moon is blocking the whole thing. Total eclipses actually only occur in specific locations, so you can't see it from any part of the world. So you could have a solar eclipse in like Winnipeg, but you won't see necessarily that same solar eclipse from the UK or somewhere else. Maybe even, I don't know, Victoria, BC. Right? Total eclipses are super rare. They happen once every 360 years from one particular location. So if you see one in Winnipeg, you happen to be lucky you see one. The likelihood of it coming back and happening again, viewable from Winnipeg, well, you probably won't see that in your lifetime. So that's kind of cool. So in a solar eclipse, the moon casts its shadow on the Earth. So at that particular point, you get like incredible darkness occurring, and then the moon moves past, and all of a sudden it's daytime again. So you get a period of just darkness. You're experiencing night essentially in the middle of the day, which is kind of cool. Don't look at a solar eclipse. That's incredibly bad for your eyes. I think last time there was a solar eclipse, wasn't in Winnipeg, but there was one either last year or a couple years ago. And you have to wear special glasses if you wanted to look at it, because otherwise it could cause blindness. And I remember seeing headlines for a rapper who was going on tour, and he had to cancel his tour because he experienced blindness immediately after watching the solar eclipse. So, crazy stuff, but also protect your eyes. Anywho, we also have a lunar eclipse, And this occurs when, again, they're all in line, the sun, the earth, and the moon, but this time the earth is in the middle. So the earth is now casting a shadow on the moon. And when a lunar eclipse occurs, it's visible to all places on the night side of the earth. So here we have the sun, boop, 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 boop. We have the moon, and we have the earth. Okay, and during a lunar eclipse, you see this kind of like reddish, orangish moon. That's because that's the shadow of the earth on the moon. But only half of the people on earth can see it, right? Because if you were on this side here, you can't see the moon anyways because the rest of the earth is in the way. If you are on this side, though, you'll be able to see the moon, and so everyone on that particular half, on the night half of the earth, will be able to see the lunar eclipse. So it's not necessarily location specific in terms of like particular cities or particular regions, but it's half of the world will be able to experience this lunar eclipse. And this usually happens about 2 times a year. So it's kind of cool. So again, solar eclipse occurs when the moon is in the middle, and a lunar eclipse occurs when the earth is in the middle. Kind of neat stuff. And if you think about it, in this diagram, come on. In this diagram here, because the moon is so small and the sunlight is beaming on the moon here, it creates just this small cone of darkness on one particular location. Whereas in the lunar eclipse, the earth being in the middle, the earth is much larger than the moon, so it creates a shadow on the whole entire moon, causing that darkness to occur not only just in a small location on the moon, but on the entire piece there. Cool things. All right. One of the last things we're going to talk about the moon is tides, right? And tides are caused by the moon's gravitational pull on the earth, which is absolutely super interesting to me. Any body of mass, so like the earth, the sun, the moon, they all have gravity. Okay, the larger an object, the larger its gravitational pull. So the sun will have lots of gravity, is able to pull in all those planets into orbit around the sun. Think back to our heliocentric model. The earth has a gravitational pull, but it's not as strong as the sun's. It's able to pull in the moon because the moon's close enough to be pulled in, but the other planets aren't really affected by the earth's gravity. The moon also has gravity. It's not strong enough to pull in planets or moons of its own, but it's strong enough that it actually affects the water levels on Earth, because water is more easily swayed than like solid objects on Earth, so it's able to move, but you're not necessarily going to have major differences here. So the moon is responsible for the tides on Earth. High tides occur when the sun, earth, and moon are all in a line. So those eclipse times are prime time for high tides. And then low tides occur when the moon is on the sides of the earth. So when everything is lined up here, so we have, I'm going to use a different color. When we have sun, moon, earth, all in a line, then that's when we experience high tides. When we have the moon over here, the sun and the earth, that's when we experience low tides. Okay. So high tides is just when our water levels are much higher. Low tides is when our water levels appear to be much lower. Actually in Canada, in Hopewell Rocks in New Brunswick, that's on the Bay of Fundy there, that's one of the places where you could experience the most drastic tides in the whole entire world. I was actually there this past summer, and over the course of one day, the tides changed about 40 meters. It was insane. But yeah, that was pretty cool. All right. Anywho, last little bit. Exploring the moon. So in the 50s and 60s, we have sent probes to the moon. Okay, so we sent things to check out the moon, but never a person in that time. However, July 20th, 1969, Neil Armstrong, he was the first man to walk on the moon. Pretty dope. Here's a photo. From 1969 to 1972, there has been 6 Apollo missions where they've collected 382 kilograms of rocks, or 842 pounds of rocks. And as of current, only 12 Americans have walked on the moon. So that's kind of neat. We've sent people to the moon. We've been able to collect rocks from the moon to do more further studying here on Earth. But moon exploration is kind of an ongoing process. We don't really have the need to continually send people up to the moon. It is something that is dangerous and that costs quite a bit of money. So if we could send machinery rather than people, that is preferable. That's why, for the most part, our Apollo missions have occurred just in the couple years that followed that first time. Because after that, we didn't really need people up on the moon where we could just send technology and equipment and then have that returned afterwards. All right, and here's a pretty dope picture of a person on the moon. I just liked it, that's why I included it. And here's a picture of our moon. So just like our Earth, there's different oceans and different land masses that have different names. Our moon, our mare or Maria, as well as our highlands and our craters, they all actually have names. And so, in case you're interested, here is a picture of some of those names. So kind of cool, because oftentimes we don't think that we name all of the different things on other planets because it's not something commonly known to us. But now, hopefully it is. And then here's a picture of our Earth taken from the moon, which is kind of neat because we always see our moon and we could see portions of it. So maybe we see a quarter moon, but we very often don't see a quarter Earth. And that's what we see from this perspective of the picture taken from the moon. Alrighty, that's it for me for today. I hope you had a very educational experience and can't wait to chat with you soon. Peace out, homies!